Mr. Field here. We're going to talk about how to find the greatest common factor, also known as the backwards distributive property. I'm going to start you today with this equation right here on the screen. 12x squared plus 36x all over x plus 3 equals 156. I'm going to go ahead and let you pause the video, and I want you to take about 5 minutes to try to solve this on your own using anything that you already know, anything that you can to try to solve this. But don't kill yourself. Don't take more than 5 minutes. Go ahead and pause the video for that now. Okay, hope you're back. All right, if you didn't pause it, shame on you. I hate that you didn't do any work on that. Okay, go ahead and use you some algebra tiles. You may need to pause the video to go get you some, and I want you to show me 4x plus 10. Go ahead and pause the video if you don't have your tiles. Go ahead and pause it for a second while you build that. Then I'm going to go ahead and build it to make sure that you did it correctly. So 4x plus 10 Okay, hopefully with your tiles you built the exact same thing. If you did not, you need to go ahead and build this. This is what 4x plus 10 looks like with algebra tiles. Now, here's my question for you. Can these tiles be divided into smaller equal groups? So I'm going to ask that again. Can you divide these tiles into smaller equal groups? I want you to pause the video and go ahead and try to do that. Okay, you should be back. If you are, I hope that you found out you could divide this into two equal groups that look like this. Okay, so each of these groups is 2x plus 5. And so, write this on your paper now. We can see that this is 2 times 2x plus 5. Now, one way we can find that is we find the greatest common factor of 4x and 10. Now, we've worked before on prime factorization. We can see that 4x is just 4 times x, and that's 2 times 2 times x. And 10 is just 2 times 5, and that's it. Well, what we can see is that what do these two prime factorizations have in common? All they have in common is this 2. And it turns out that 2 is what we can pull out and put right here. So both of these have 2, and then knowing our distributive property, doing our shoop lines, that's how we get that. So I have some practice exercises for you today to use on a sheet of note paper. So we're going to go ahead and find the greatest common factor of 12 and 20. You should pause the video and go ahead and find the greatest common factor of 12 and 20 because that's easy. Okay, I want you to go ahead and find the greatest common factor of 12 and 20. That's pretty easy. Go ahead and pause the video and do that, and then come back when you're ready. All right, I hope you're back. 12 and 20 are our greatest common factor. 12 can be broken down into 3 times 4, which is 3 times 2 times 2. 20 can be broken down into 5 times 4, which is 5 times 2 times 2. You say, what do these two things have in common? Well, this one has 2 times 2, and this one has 2 times 2, and that's 4. So the greatest common factor of 12 and 20 is 4. There's another way to do that, and the other way is this. You take your two terms, 12 and you have 20, and you list the factors for both. Now, I like to factor from the outside in, so I go like this. I go 12 is 1 times 12. It's also 2 times 6. Next number up from 2 is 3. It's 3 times 4. Next number up from 3 is 4. I've already got 4. I've met in the middle. Those are the factors of 12. I did the same for 20. 1 times 20. 2 times 10. 3 doesn't go into 20. 4 times 5. And I've met in the middle. My next number up is 5, and there it is. Well, what's the biggest number that's on both of these lists? Well, 1 and 1 are common factors. 2 and 2 are common factors. 4 and 4 are common factors. And that's it. Well, 4 is the greatest common factor. So 4 is my greatest common factor, just like I found. Okay, same deal with 54, 36, and 45. 54, 36, and 45. Well, I can break 54 down. Let's see, that's 9 times 6. And that's 3 times 3 times 3 times 2. 36, I know is 9 times 4. That's 3 times 3 times 2 times 2. Did you see me skip some steps there? I'm a step skipper. And 45 is 9 times 5, which is 3 times 3 times 5. However you want to do it. Okay, what do these all have in common? Looks like they all have a 3 times 3. That's 9. Our greatest common factor is 9. Again, you can do that by listing the factors of all of your terms, 54, 36, 45. So 54 is 1 times 54. It's also 2 times 27. It's 3 times 18. It's 4 times nothing. It's 5 times nothing. It's 6 times 9. And my two numbers left are 7 and 8. Neither one of those go. Okay, 36 is 1, 2, 3, 4, 6, 9, 12, 18, and 36. 45. Let's see, I got 1 and I got 45. 2 doesn't go. 3 does. It's 3 times 15. 4 doesn't go. 5 does go. It's 5 times 9. Now look, all my numbers between 5 and 9 are 6, 7, and 8, and none of those go. So I'm done. Looks like the biggest number on my all three lists is 9. 9 is my greatest common factor. All right, here's the more difficult one, but it's still doable. Take 16xy squared and 30xy. This is 16 times xy squared. That's 4 times 4. That's x. That's y squared. Okay, that's 2 times 2. That's 2 times 2. That's x. That's y times y. Okay, I'm done here. 30xy. I'm just going to go ahead and make 3 branches here. It's 30. 15 times 2. 5 times 3 times 2 times x times y. So what do these all have in common? Let's see. Well, they all have an x and a y. They all have a 2. And that looks like that's all I have. So the greatest common factor here is 2 times x times y. Okay? All right. Good stuff. Now, let's bring this up a notch. And let's call it the reverse distributive property. So if I have a term called 2x plus 6 and I want to factor this, then I want to find the greatest common factor of 2x and 6. Well, this is 2 times x. This is 2 times 3. The biggest thing they both have is 2. So my greatest common factor is 2. And I want to know this thing right here is 2 times something. Well, 2 times what is 2x? I hope you said x. 2 times x is 2x. And 2 times what is 6? I hope you said 3. Okay, so here's our answer. 2x plus 6 is 2 times x plus 3. Okay? Let's try this one. Now 16x squared plus 30xy, we already know from before that our greatest common factor is 2xy. So this is going to be 2xy times something plus something. So how many times will 2xy go into 16xy squared? Well, 2 times 8 is 16. X times 1 is x, so I don't need to put a 1 in there. And y times y is y squared. So this is 8y. And then 2 times 15 is 30. And x times 1 is x, so I don't need to put a times 1 here. And y times 1 is y. So that's it. So 2xy times 15 is 30xy. You might want to pause this video and go back over that one. that's getting a little tough. And that brings us to the big tough problem of the day. All right, now anybody with a third grade education can do this problem. I'm just kidding. It's really actually a little tough even for 7th graders. But here's how we're going to do it. You got to factor out this top expression. Okay? So you may know now, if you look at just this top, how to factor that. You're going to find the greatest common factor of these two terms. Okay? And then you should be able to simplify this fraction, and you should be able to solve that. Okay? What's the greatest common factor of 12x squared plus 36x? That's your question. I'm not telling you the answer. You can save that all the way over the weekend until you can solve this whole equation. But this is all yours. Good for you. Good luck. Don't forget your homework is page 159. No, it's not. Your homework is page 194, number 36 through 42. Good luck to you. Have a great weekend, and we'll see you when I get back.